the beginning of my internship, I thought that the main question is how does this equipment work? And the end of my internship, I understood a more main question that is how does a huge system, a huge industrial system, work safely and reliably as one system? That shift from my understanding as an individual component to understanding a complete system was the most important thing that I have learned in the internship. My name is Ahmed Mamdouh. I am an electrical engineer at Qatar University. Uh, I completed my practical training at CCC on the North Field East project, the NFE project, which is the biggest project in oil and gas in the entire world. I have been exposed to many activities, site operations, disciplines. How does the internal company work? How does electrical engineers coordinate with many disciplines like mechanical, piping, civil, all of them? Uh, First, on the first thing said, I have learned that a successful industrial project is never completed by one engineer or one department. They are all working as one department. They're all working as one team. Engineering as a department prepares the drawing and specification, procurement supplies the approved materials, and planning checks whether the work is ready, and lastly, chess ensures that the activity can be completed safely. Constructions is the one carries out the installation. QA/QC is the one verifies that the completed work meets the project requirements. I have learned that having an approved drawing like this one is not enough to start an activity. The material, the access, the manpower, the tools, the permits, the safety requirements, the inspection points, and all of that must be ready. I have also been exposed to a real testing of a motor, which have been explained to us in the university, and I have seen it in real life in the site. This changed my understanding of engineering. I started to see that it's not only as calculation and equipment selection, but as a coordinated process that connects decisions made in the office and performed on the site. That's how we did our orientation in the NFE project as trainees. From the electrical perspective, I developed a clear understanding of how power moves from the source to the final load. I studied transformers, switchgears, distribution panels, cables, lighting system, motors, UPS systems as a backup, protective earthing, cathodic protection, which was a new concept for me. I also understood the importance of redundancy. A backup transformer or a cable is useful only when the complete backup path is correctly rated, separated where possible, protected, tested, and ready. There is always, in these big projects, there is always a backup for anything. For example, an FO cable, which is a fiber optic cable, which is used as a communication system in the site. They are not using only one, they should use two or three as a backup. So at any emergency, everything should be ready. We have been exposed to electrical as a general concept. They had two sections in the electrical. They had electrical and instrumentational. Electrical was Electrical work was on lighting, PAGA system, HVAC systems, and telecom systems. For the instrumentation, they had the transmitter. The transmitter had many types. One of the types was the temperature transmitter, the level transmitter, and the pressure transmitter. They all had the same concept of working, and they used, as I've learned, they used 4 to 20 milliampere signal. It was a communication between the main control room and the transmitters, so they can control the whole process. If you are going to talk about everything that we have taken on the site, a 5 minute video will not be enough to talk about everything. Well, thank you very much, Engineer Omar and Engineer Ryan, and every engineer I have been with in the site and in the office, and hope you get hope you get successful in your life too.